What do you mean?
Because, well,
We're rolling here. So tell me.
alright, you know how like you have to press Trig?
Yeah.
That's the thing?
Yeah.
Well, would it just be like you just
Could you type? Why don't you try it? I know that if you press the trig button, the inverse is right there underneath with the little -1. So you might have to just use that. Even though when you see arc, it means, again, inverse as the video's rolling. So arc sine means inverse sine, and so on. And you can see how the x and y are flipped around. Now, there are domain and range restrictions when we talk about inverse. This does not go on to infinity or negative infinity in terms of that. So for tangent it does here, but I need to recognize that when you do inverse, you're looking for an angle. You're given the point on the unit circle. You're not looking for the point, you're given it. You need to find the angle that goes with that point. That's inverse. So when you're looking for the angle, there is only one right answer because there's a restriction. So I just need you to look. For sine, can you see the restriction of where the angle is? Between -π/2 and +π/2. That means that when it's negative, it's going to be a negative angle in quadrant 4. So for arc sine, it's quadrants 1 and 4. Let me finish my thought. For arc cosine, you're going to be given a point, right? And you need to find the angle that goes with it. For cosine, arc cosine, it's quadrants 1 and 2, and the angle will always be positive. And for arc tangent, it's the same as arc sine. Quadrants 1 and 4, and in quadrant 4 it's written as a negative angle. That's pre-calculus, and particularly if you're a Math 3 honors, you may not have the foundation yet. So we're going to do it right now. So example number 1 says, graph the indicated inverse trig functions in the coordinate planes below. So if I was going to graph this, notice that x and y have been inversed. So that means at 0, right here, that's actually the point. So when I think of the unit circle, and I say, okay, there's my unit circle. At 0, what's the value for tangent? 0, right there. And if I flip it around, which means if I give you the answer, which is 0, what angle is that? 0. Now, if I move on towards the other coordinate, so up here at π/2, do you see π/2? Oh, this is for, what are we doing? Sine. So at π/2, what's the y coordinate there? 1. And we flipped it around. So when the x is 1, what does y equal? π/2. And then for negative π/2, where do you go in the unit circle? At the bottom. What's the y coordinate there? And we flipped it, so now it's the x coordinate, right, is -1, and then what's the value? What's the angle? Right? And then we connect it. That's what the graph looks like. And they're endpoints. It doesn't go on forever. It ends there. How about for arc cosine? Same idea. You have a unit circle. What you're given is, when cosine is 0, what angle is it? No. At π/2. Up here, right, on the top. In other words, cosine is the x-coordinate, right? So when cosine is 0, what's the angle? π/2. When cosine is, when it's 1, what's the angle? So when cosine equals 1, what was the angle? 0. And when it's -1, that's over here, what's the angle? What's the angle over here on the left? Pi. What's the angle? Pi. Connect it. It's not a straight line. It's curved as it goes in. And last one, tangent. Same idea. You can draw a unit circle. At what angle is tangent 0? At 0, right? Now, what happens at π/2 and negative π/2 for tangent is there's an asymptote. It's undefined. So it's undefined. Usually they're vertical, right? But because it's inverse, it's now horizontal. And this is one that does go on forever. See how I circled it? So it goes forever to the right and forever to the left.
Well, tangent would be flipped the other way, right?
Hmm?
Flip both ways.
We don't do those. So there's going to be special derivative and integration rules for these that we need to know. This is still pre-calculus. So let's keep going. Some may find this helpful. I have no idea. Do you see the unit circle right here? It's what it's communicating is where it's valid. For arctangent, it's good from negative pi over 2 to positive pi over 2. There's holes because at those angles it's undefined. Look inside. See arc cosine? Where would you find the angle? Quadrants 1 and quadrant 2. And for arc sine, where would you find the angle? Quadrant 1 and quadrant 4 as a negative angle, and the ends are included. It's not undefined at pi over 2 or negative pi over 2. It's just a way to look at where the restrictions are. So the big point is inverse trig means you're finding the angle. Arc and inverse mean the same thing. Inverse trigonometry means you don't know the angle. You're looking for the angle. You're given the point, right? It's been flipped. All right, the two biggest mistakes that students make with inverse functions are putting an inappropriate range value. That means they forget where to find the angle. And putting more than one range value so that they write down more than one angle. There's only one correct angle for inverse trigonometry. And you find the angle, you can use this diagram if it helps you. All right, turn the page. Again, whenever it ends, I'm going to continue the video during my prep. So, explain why arc sine equals that, but arc sine equals that are not true, even though sine 7 pi over 6 equals sine 11 pi over 6, and so on. So, if I said, at what angle is the y-coordinate negative a half? And you could write down 11 pi over 6 or 7 pi over 6. What's wrong about that? That is not within the domain restriction, right? That you have to find the angle in quadrant number 4, and it's written as a negative angle. So the only correct answer there would be negative pi over 6, because that's what falls in line, right, with where the restriction is. Same thing here. Evaluate without a calculator. I'm just going to keep going. What angle is tangent positive 1? What angle would the value of tangent be positive 1? And it's when root 2 divided by root 2 over 2, that's what equals 1. So what angle is that? Pi over 4. Where is arc cosine negative 1? So in other words, negative 1, 0. What angle is that? Which one is it? Pi. This one. Where is the y-coordinate negative 3 over 2? What is the reference angle? What would the radian be? Be over 3, and it would be negative pi over 3. For the next one, D, arc sine 2, you would write down, there is no point on the unit circle for that. All right, I'm going to do the rest. Part 2, and I will see you after school, I hope.